In this video, I want to review some things about the normal curve, and then we want to start standardizing this with the z-statistic so we don't need to only use parts of the curve that are perfect amounts away in terms of standard deviation. So this first problem is review. It says the amount of time one must wait for a pizza delivery is approximately normally distributed with a mean of 36 minutes and standard deviation of 5. I'm going to pause the video and I'm going to fill in our normal curve real quick. Okay, I've actually pasted in the one that we had used in a previous video with the percentages already in there. So the first question says, what percentage of pizzas take longer than 41 minutes? So we come down to 41 minutes and we add up those percentages and we get 16%. Okay. What percentage of pizzas take between 26 and 31 minutes to arrive? So we look down here between 26 and 31, 13.5% of the pizzas. And if you waited longer than 84% of other customers, how long did you wait? So you began just kind of adding these percentages up until you get to 84%. Or you could pay attention to part A, which was, the complement. It was 16%. You could say, well, it's that 41-minute mark. Now, as I kind of alluded to in a previous video, if these percentages are standard, the 68, 95, 99.7, 1, 2, and 3 standard deviations from the mean, it follows, I think, that since the shape is the same and those percentages are the same, that we wouldn't have to limit ourselves to just 1, 2, and 3 standard deviations away. And we could say, well, what percent is within 1.5 deviations, or 1.6, or 1.78? And the statistic we already have that standardizes that is called the z-statistic, because z tells us how many standard deviations away from the mean are we, right? This is our formula for z, and this whole calculation just says, how far away from the mean are we divided by standard deviations. It is how far in terms of standard deviations are we away from the mean. And once we have that statistic, if z is 1, we're 1 deviation away. If z is 1.3, we're 3 deviations away. Once we have that statistic and we know the curve is normal, we can find the percentage. Now, in old days, we used to use a table to do that. Now we use technology. So let me explain how we could do this using some technology. Okay, so I've done a couple of things here. You see on the top, I have a couple of directions for the old calculator, and I have some things on the side for the new calculator. But here's what we're going to do. We have a normal curve, and I want to know if z is 1. So remember, that means you are 1 standard deviation above the mean. I want to know what proportion lies up there. Okay. Now, if you have a TI-83, if you go to your calculator, you're going to press second vars. Okay, make sure you're finding that second, and then vars is down in here. And I know my calculator is real small, but second vars, you'll get a list of distributions. And you are going to choose normal CDF. And you look at this picture, and it's z lower bound, z upper bound. Your lower bound, your z is 1. And your upper bound, you have to just type in a very large number. Let me drag in what I chose to type in. And by the way, if you have a newer calculator like a TI-84, you actually get this. You get kind of a fill in the blank. Okay. Lower bound is 1, upper bound is 1E99. So this is 1 with 99 zeros after it. Okay, so very big number. And you're just going to leave a mean of 0 and standard deviation of 1. So notice if you have the old calculator, it won't ask you for the mean and deviation. That is just assumed. Okay, so let me drag this in. And this one looks kind of standard. Okay, when you hit paste on the 84, you'll get this. And again, this looks very similar between calculators. So your percentage is, or your proportion is 0.1587. And remember, yesterday we found that, the 68, 95, 99.7, we said, well, it's 16% is above 1. And that really is, you'll notice if you round, it's 0.16. Okay? All right, let me pull in something else. So in this curve, we're going to do z less than 2.1. So if you have a normal curve, 2.1 is up here. Because again, that means you're 2.1 deviations above average. And you want to know the percent that's less. So here's how I might type that in to my calculator. Okay, and notice the negative. So this is -1 with 99 zeros after it. So this is a really large negative number. So really negative. And so from down here, and the upper bound is 2.1. And I left the mean and deviation. If you have the TI-83, you don't need to put that. That is just built in, that it's going to be 0 and 1. So you think there's got to be an awful lot of data down there, and there is. 0.9821, 98% of the data is below, I forgot the 8, is below that Z statistic. Okay. So let me push that to the side. Now, the next question says, well, what about a Z between -1.1 and 1.4? So now these will serve you. You won't have to do the 1E99 because these will serve as your lower and your upper bound. So let me drag in the calculation for that. It's right here. Okay, you see normal CDF. So I've got lower bound, upper bound, and again, in the color of the 84, you have to put that in, but in the old one, you would not. 0.7836. Last question on here is what? I place a Z. I have a Z statistic such that when I'm greater than that, the area is 0.4. Okay, I didn't draw the previous one. I'm sorry. Let me, if I quick do that, it's -1.1 and 1.4. It helps to draw the picture to see what the bounds are. This is such that I have an X, where 40% of the area lies above. And I want to figure out what the X is. Well, this is nice. There's something on the same spot on our calculator. If we do second vars, so second vars, right below the normal CDF is inverse norm. An inverse norm will allow us to work backwards and say if I know the area, I can figure out what the Z statistic was. This area is the area that's always to the left or below. So you're going to have to do just a little bit of math here in your head and say, well, I want 40% to be above, so 60 or 0.6 is below. Let me drag in how this looks on the color calculator. It looks like this. Okay, 0.6. So when you paste it, it looks like that. So this right, let me circle it. This is our Z statistic that would give 40% or a proportion of 0.4 above. So this is a kind of nice way. You don't have to use a chart, and we can actually calculate proportions and percentages that don't lie perfect amounts of deviations away. In the next video, I want to show you some more cool things the calculator can do and show you the work that's expected on the AP exam for questions like this.